So the point being mentioned is that the book talks about arrays. Python supports lists. Python does not support arrays. No big deal, because a list is a super form of an array. An array is fixed in length, whereas a list grows and shrinks as you need it. So it's much more flexible. So why do you have arrays at all? Because they are faster. Python is not a fast language, really. So if you're going to write a video game or word processing software or something, then it doesn't really matter that arrays would be faster. But the reason why is that, as the book explains, arrays are contiguous in memory. And so when you're working with them, they're all right in a row. They could all be loaded from disk in one fell swoop. The program can say, okay, I need this series of data, and they come to the memory. Or they can be cached in the chip's local, because chips always have some memory, some really fast memory on the chip, and then they have this lower RAM, right, that if you're going to hold up, the array can be cached in the RAM. The list is not contiguous. There may be some pieces of the list in one place of memory. There may be some pieces in another. The reason for that is that since arrays are contiguous, they get allocated and they're all 100 entries. They're just sitting there right there in a block. But since lists grow and shrink, as they grow, it's what are you going to do? What if there's stuff after the first part of the list and stuff before that part can't change, so it goes and adds some more memory somewhere else. So arrays are faster. That's their chief advantage. There's really no other reason why you would prefer arrays over lists. So when you're talking about an array, what is it? It's a series of values, series of integers, series of strings, series of floats, a series of turtles, whatever. You can have, a series of student names, a series of song names, a series of file names, stuff like that. So they all share the same name. What does that mean? One variable holds all that information, and they are of the same data type. Trying to see if we've mentioned that here. I'm not seeing that quite mentioned here, so I don't think that I'm reiterating too much. Our last notes do note that arrays are fixed in length, so we're going to pretend a lot that we are dealing with arrays, just because you have to have the concept, and then let's just build upon that. So we're in lecture T. We're in chapter 6, arrays. So lists are a series of values of the same type. Excuse me, arrays. I need to call them arrays, even if Python calls them lists. Series of values of the same type that are accessed with one name and a subscript. So you might have an array called students with 100 elements. It's made of strings, so that it's got 100 strings in it. And you access the elements with this name, students. Each item in the array is called an element. So you might have students, that would be the first student. We might have 99, that's the last student. Now Python's got a weirdness that other languages don't support. Normally you cannot have negative subscripts, right? If you have 100 people standing in line, the newest person, -1. Well, Python actually does support that. It just starts going from the end. -1 is the same as saying the last element in the list. So since this one has 100 elements in it, if we had put -1 there, it would mean the same thing. And -2 would be 98. And -3 would be 97. So I'm going to add a comment here that since students array is 100 elements long, we can access elements 0 through 99. Because that adds up to 100 items. You're just starting counting from 0 rather than 100. So since students array is 100 in length, you can access subscripts, also known as indexes, 0 through 99. Why does Python give you that -1 business to get to the last element of the array? Because otherwise, if I don't know the length of the array, I have to ask the array how long it is, and then I have to use that result in order to get the last element. So the last element in any non-empty array is array name, subscript, len subscript, array name, in subscript -1. So our students array, that was 100 elements long. Well, the length of that array is 100, so the last element you can get to, the last one in the list, is 99. Sure would be nice, and this is true of Python, and I haven't seen it in other languages, and it's one of the things I love about Python. In Python, you can do this. You can use negative subscripts. So, you could do this. Array name, -1. Right? You can kind of see what they did there. These mean the same thing, but you can see that -1, right? -1. So if you wanted the second to last element, you'd put a -2 there. Well, -2 there, right? Third to last, -3, -3. So this is a shortcut for not having to type that. Kind of convenient, you know. I don't want to have to type len parentheses, a whole bunch of stuff in parentheses in order to, you know, get the last element of the array. We're not going to take advantage of that too much in this lecture, but maybe in future lectures. Certainly the book's not going to talk about that. So as I mentioned, you can allocate an array. You specify how many elements and what their type is. Why don't we actually do this in code? We're going to make an array of student names, but we're not going to make it 100 long. That's a bit much, right? We're going to make it maybe 5 elements long. So in this language, here's how you do it. S names, short for student names, equals. It's going to be a series of strings, so I'm going to put a square brace. You see these square braces an awful lot when talking about arrays, talking about lists. A double pair of quotes, in square brace, times the length. Now I think last class I reversed the order of it. You could do or 5 times identical results. This is the data type right there. If there were numbers, you'd put a 0 there. So like student IDs might be numbers. So student IDs. I don't really like seeing SIDS there. Sudden infant death syndrome. But we'll go with it. These are going to be numbers. So we say 0 to represent integers times 5. Again, it could be 5 times subscript 0. Let's print those out. Print, parentheses, S names, comma, SIDS. I'm just going to print both of them. All right, and there we see our array of 5 empty strings and our array of 5 zeros. Now if you stuck something else in there, like the word Bob, and you stuck a different number in here, like -123, and then you run it, okay, it created an array of 5 elements, all of them set to Bob, and then another one of 5 integers, all of them set to -123. And you're not going to normally do that. You're normally just going to assign them empty values, which you will then later on fill in. So I'm going to take the Bob out, and I'm going to take the -123 out. That was just to illustrate. So now that we have S names, let's put a student name in there. S name subscript 0 is equal to Tony Stark. Except I made a mistake. What's wrong with this statement? What's wrong with the variable name I chose?
It doesn't have S.
Yeah, I didn't choose the right. There we go. And then SIDS, well, he's pretty proud of himself. He's the first student. Nah, I'm not going to do that. Let's say he's student 1001. And then S name's 1, going to be somebody else. We're going to skip over to DC, Clark Kent. And SIDS 1 is equal to 2098, whatever, right? And so then I'm going to print S names, and then I'm going to print SIDS, student IDs. These are known as parallel arrays because they're of the same length and the items are linked by their index number. What do I mean by that? Well, we'll run it and it'll be real obvious. Alright, so like the first element is Tony Stark, that's his student ID. The second one is Clark Kent, and that's his student ID. So this is subscript 0. We saw that when we were creating it. This is student ID 0. We saw it when we created that one. And then Clark Kent, our second student. So we used S names 1. The second student ID was 2098. And so that was also subscript 1. So that's a parallel array. I'm going to add a comment to that effect. Two or more arrays of the same length where the elements are conceptually linked. Maybe I'll skip the word conceptually. They're conceptually linked by their subscript, parentheses index. Just like you have furniture being delivered to your apartments. My examples are always silly. And so some furniture is being delivered to apartment 1, some furniture is being delivered to apartment 2. They're coming in separate trucks. But as long as they have which apartment number they're going, all the furniture is linked together because they're all going into apartment 1 and all the other ones are going into apartment 2. Letters in a mailbox, right? A lot of them go into 1. Those are all conceptually linked because those are all to you, hopefully. And then your next door neighbors got a different ID, different address number on the street. So that mail is coming to them. So they get put in another, and they all share a different index number, a different street address. So go ahead. Why don't we change this just to 3? Instead of 0 times 5, let's just do 0 times 3. Because I want y'all to add one more S name and one more SID. Just pick another name and another student ID, it doesn't matter what.
DCMO.
Whatever. Image.
Oh, okay.
Anything like that. Doesn't Star Wars.
We'll go with Mark Grayson.
Sandman. I really don't know my comics very well, but I had friends who collected them in the 90s, so I know names from them. All right, so I think I'm going to make one up. I should wander around and make sure everybody else has got it. Anybody stuck on this concept? Anybody having trouble adding a third name to their list? Wave your hand, no shame. All right, so S name subscript 2. So you go to Sandman. I know that name gets used in all the universes. SIDS, subscript 2, he's got a weird ID. He's number 9998. So when I run it out, now we're going to see all three elements in our parallel arrays filled out. Tony Stark, that's his ID. Clark Kent, that's his ID. Sandman, that's his ID. So, let's add one more array to our set of parallel arrays. I don't know, city where they live, planet that they're from, their favorite food. Let's do food. It's always silly. So I'm going to come down here and tack on one more array. Foods. Foods equals. These are going to be strings so that we can put in, like banana cream pie and stuff. And again, I want 3 of them because since these are parallel arrays and we have 3 people we're talking about, we need 3 elements in that array. So Tony Stark likes Fritos because they come in a bag similar to his armor. Food subscript 1. What does Superman eat? Breakfast of Champions. Wheaties. I think that's correct. I mean, the correct name for that slogan. And then food subscript 2. I have no idea what a Sandman would eat, so we're just going to put, moon rocks.
Sandwich.
Pardon me?
I said a sandwich.
Yeah, sandwich. There we go. If you did Sandman, whatever. You did your own third character. You can put anything you want in there. Now we're going to write a for loop that goes through the arrays. I really want you to memorize this syntax. Really, really, really. What you got to do is use a range statement to increment an index counter to 0, 1, and 2. So our range is going to be 3. However, hard coding 3 is kind of a bad idea, although we did it everywhere. It'd be better to ask one of the arrays for its length. So, for I, standing for index, in range, subscript, I could just put 3, knowing in advance that there's 3 elements in it, but I should have defined this as a constant. I should replace all these 3's with a variable name. It's correct, though, to ask the array how long it is. And since these are all of the same length, it doesn't matter which one. I'm going to go with S names. Before I make the change that I'm about to make, I'm just going to print out the S names. That'll make absolutely clear, and this is the example I want you to memorize. So, S name, subscript I, in subscript in parentheses. And that's going to print out our names in order. Right? Printed out the names in order. Please memorize this syntax. If you wanted to print out the food instead, you just put foods there and there. Right? Student IDs, you just put SIDS there and there. But since we have parallel arrays, let's print all three of them out at the same time. Same syntax here. I could even just copy that rather than type it in again. Right? Because again, we're going to count from 0, 1, and 2. And I'm going to print out sname subscript I, comma, SIDS subscript I, comma, foods subscript I, in parentheses. So I'm going to run it and then I'll bring the code back. And here we go. Tony Stark, student 1001, likes his Fritos. Clark Kent's awfully fond of his Wheaties. The Sandman eats a sandwich. And you see what we did. They were thematically linked by their index number. If we replace that with 0, 0, 0, and then we had another print statement that printed out 1, 1, 1, and another one that printed out 2, 2, 2, we'd get identical. Now what if we wanted them all fancy-like? And what do I mean by that? Evenly lined up. It's worth knowing how to do that. So we're going to copy this one more time. And then this syntax is going to be a little bit more complex, and we've seen this occasionally, is when you use the % sign to specify. Previously we've been doing like %.2f to print, two numbers in a floating point after the decimal point. Instead, we're going to be specifying the width so that this is all lined up in columns, like a report. So print, parentheses, quote, and I don't know, let's put 15 spaces in each column. So %15s, space, %15s, space, %15s, end quote. After the quote, we have another % sign because we're going to start filling in those placeholders. So % there, and then inside the parentheses, we're going to put these same three things here. If you feel like copying them, that's great. If you feel like typing them in again, that's fine. I may wind up going to the next line because it's about to scroll off. sname subscript I, comma, or in subscript, comma, SIDS subscript I, and comma, foods. Now you didn't have to go to the next line. And then a closed parentheses to match that one. And then a second closed parentheses to match that one, because you always have to match the number of parentheses in your statement. And there we go, they're all lined up. They are right justified. We might want our text to be left justified. I'll show you how to do it and then I'll remove it just because it makes the syntax a little bit more confusing. If we put a minus sign in front of the number but after the % sign, that left justifies. And you know what I mean by left justification. It means they line up to the left margin rather than the right margin. But I may take those out. And there they go, right? I think that looks a little bit better than it did before. I like my numbers being lined up like that. If you like them being lined up the other way, feel free. I'm almost tempted to leave it like that. I will. Leave out the minus signs if you want the data elements to be right justified rather than left justified. The improvement in my mind is so great that it's worth throwing that syntax at you. What's the last thing? If this is a real report, we'd want to put a header, right? We'd want to know what each column was, just like in Excel. Well, let's print a header above that for statement, but I better stop and make sure that, let's make sure that we're all doing okay. Here's the problem I'm seeing, is that we declared 3 foods, because I told you to. I also snuck back up, and I mentioned it, but right, when you're typing stuff in, you can't follow everything I'm doing. These need to be 3s as well, because parallel arrays all have to have the same length. So go back up to the definition of S names and SIDs and change them to 3. Right, so I'd like to add headers. I want each column to describe what it is at the top. Right? So I'm going to go above our last for loop and add a print statement to put the headers. I want the format of it to exactly match what we have here. So our print statement is going to look exactly like this one. So you could just copy that line. That'd be the fastest way to do it. You can see I'm awfully fond of copying rather than retyping. So I'm going to copy that last print statement, paste it, but it needs to be unindented. So if you paste it and it's indented, undent it. Why are you looking like that? All right. But we're not going to print out the name and the ID. We want to print out some column headers. So student name, there. And the second one, instead of SIDS, let's just put ID, or student ID. I guess it could be name and student ID, right? We could put whatever we wanted to in the column headers. And instead of foods, we're going to put a quote. Favorite food. Maybe we'll change some capitalization. All right, and again, you did not have to space out and hit return like that. I did it just because I didn't want it to scroll off the screen. All right, student named, ID, and favorite food. And if we felt like doing a second line that was, you know, a number of dashes, make it really look like a report, I think that's about enough, but you know what you would do. You'd copy this print statement, paste it underneath it, and you'd change student name just to a series of dashes. Student ID to a series of dashes, and favorite food to a series of dashes. Heck, why not? Since I mentioned it, I'm going to copy that header, I'm going to paste it below it, and I'm going to change those things to dashes. And by the way, if you hit the insert key, if you could find it, you'd go into overstrike mode rather than insert. I'm not going to bother trying to get that to work, so I'm just going to type all the dashes out to about the same length, right? I don't care, maybe I'll make them all this exact same number of dashes, whatever looks pretty. It can take some tweaking, right, to get it to look right. I think that's looking good. We have a problem, though, if the student name winds up being longer than the 15 spaces that we allocated for it. What it would do is it would push everything over. So for example, don't make this change, because I'm going to undo it immediately. If it was not merely Clark Kent, what if I made Clark Kent, comma, or parentheses, Superman? Right, that's way longer than 15. It no longer fits into the 15 characters. It might be nice if it chopped it off to make it fit into 15, but it doesn't. Instead, it just pushes everything over. So you can have a little bit of a problem, and you can kind of wrestle with it to try to fix it. You could just extend the width of it. You could find a way to truncate the length of it by using slicing. I don't want to make our example more complicated, so I'm going to go back and undo my change. All right, now that we've added the headers, anybody's code broken? Nope. All righty. So they all have the same name. At least each one has its same name, right? S names. S name subscript 0, S name subscript 1, S name subscript 2. They all share the same name. They just have different index values. Each index value can be treated like it's an individual piece of data. What do I mean by that? You know, now we're going off in a completely different direction. If I did x equals 1, y equals 2, and z is equal to 3, x plus y, right? That all looks very familiar. You can use array elements for the same thing. So I'm going to say that Sandman is weird, and his favorite foods is equal to the favorite food of Tony plus, why not a space, plus the favorite foods of Clark Kent. Right? So I'm treating these just like they were single variables. So anything you can do with an array, with a single variable, you can also do with an array element, as long as you're indexing them. Here's what would not work. If I took that off and that off, no, that's not going to work because this is an array. It's not a single string, and that's not a single string to be concatenated together to create a food. So don't do that. Don't do that. Oh, I didn't print out the foods too. But that's just an example, right? If we printed out the list again, I have no idea what it would look like. I'm curious, so I'm going to copy and paste this, but then I'm going to delete it. So, just because I'm curious what it would look like. Right? And so, Sandman likes both Fritos and Wheaties. And I'm going to undo that print statement. That's not really that important. So since we're talking about arrays, we're going to pretend that this is true in Python, but it's not. That they're all arranged contiguously in RAM. That all the elements are one after the other for speed of access, to make it easy for the program to come in and manipulate it. So that's the price you pay for using lists rather than arrays, is that lists are more flexible, but they're a little bit slower. So you make that decision when you're implementing them if you're trying for maximum speed. Now, like I said, Python is not a maximum speed kind of thing, so the guy didn't implement arrays. So every element is an item in the array. Here we have an array of 3 floats. 25 is an item, an element. 36 is another one. 4799 is another one. Tony Stark was an element. Clark Kent was an element. Each array element is the same type. All the student IDs were integers. All the foods were strings. All the names were strings. Each element is differentiated by its subscript, which has to be a whole number, right? Would this make any sense at all? Print parentheses, and don't even do this because I mean you can type it and comment it out. S name subscript 1.5. What in the world does that mean? And yeah, I know that, you know, in Harry Potter there's a train station that has, you know, something in 3/4, you know, train stop or something like that. But in real life, we need whole numbers to differentiate things, right? That would not possibly mean anything. What's it going to do? Half of Clark and half of Sandman? Nah, that's not going to work. So I'm just going to delete that, put error, or not delete it, I'm going to comment it out, and I'm going to add a comment that subscripts Must be whole numbers. We're going to get to the point where it mentions constants and arrays. What do we mean by that? We could have done something like this. Say we have something that's going to keep track of the sales for each day. We could have done something like this. Num underscore days is equal to 7. There's 7 days in a week. And then we could have allocated sales out to that amount. Sales, not sakes, sales equals, and these are going to be numbers, so I'm going to put 0 or 0.0, whatever. Sales might be floating points, so maybe I'll do that. Times num days. And then I could use a for loop that was based on this num days, you know, for I in range, parentheses, num days. Now we don't have any data, so it's going to print all zeros. But that's okay. For I in range, subscript, num underscore days, in subscript, colon, print, parentheses, sales, in parentheses. Whoops, what did I do wrong? That's the array name, but how do you get a hold of the elements in the array? If I want the first element in the array, what would I put? I'd have to put a subscript. But I don't want the first element every time. I want the one that our counter is going. And of course, since we didn't put any data in, whatever. The next thing the book mentions is that you could use constants as the subscripts. What do we mean by that? Monday might be day 0. So I'm going to put caps, Monday, or maybe just MON, equals 0. Tuesday, TUE, equals 1. Wednesday equals 2, not 3. And so on, all the way down. I could put in more days. And then so I could use that to assign values in it. Sales subscript MON in subscript is equal to, we sold, I don't know, 899. That was our sales for that day. Sales subscript TUE in subscript is equal to, you know, a different value. It was a really bad day. We only sold $45 worth of stuff. Sales Wednesday was gangbusters, and so we sold 1200.01, right? Somebody gave us an extra penny. So you see what we're using the constants for. We could use a constant to declare the size of the array. We could use a constant in order to control our for loop, and a set null value for the for loop. And we could use the constants to address the elements of the array. Why would you want to do that? Because it's kind of clear, right? Sales subscript 0 is equal to that. Sales subscript 1 is equal to that. This makes real clear that's the first day's sales, and that's the second day's sales, and that's the third day's sales. That's probably enough of that example, but let's print the items out one more time. And I'm not going to use the constant num days. I'm going to go back to using the len function, just because that's what I absolutely want you to memorize. So, for I in range subscript len subscript, what's our array called? It's called sales. In subscript colon. Print parentheses quote. Sales, let's not make it all special. Sales subscript I. But wouldn't it be nicer if it said Monday you know, and then had a dollar sign sales, and Tuesday and a dollar sign, and Wednesday and a dollar sign. We could create a parallel array, right? We've seen how to print multiple columns. This is called using an initializer list, or an initialization list. It's a different syntax. Firstly, typos, errors. Nope, nope, nope. All right. So let's make an array called days. But we're not going to do this business of that times that. Instead, we're going to directly fill it in with some values. So we're going to initialize it with some values. We're not going to declare it and then assign them individually afterwards, because we'd have to assign, 7 different values. We'd have to say Monday on one line and Tuesday on the next one. We can do it all in the same line, right? Monday, end quote, comma. Tuesday, end quote, comma. Wednesday, end quote, comma. Thursday, end quote, comma. And if you feel like doing the whole names, that's fine. I just did that so that they would all line up in a row. Friday, end quote, comma. You can see where I'm going with this. I'm going to the next line. You don't have to. Saturday, end quote, comma. Sunday, end quote, comma. And then close my list, my array. There. I've initialized my array. Kind of pre-filled it with data, right? So that I didn't have to do day subscript 0 equals mon. Day subscript 1 is equal to 2. So I'm going to make a comment to that effect. The above is called initializing an array using an initializer or initialization list. And the syntax for all these things differ language by language, but as long as you have the concept, you can Google the syntax real easy. Once you learn one language, learning the second language is like 1/3 as hard. And then learning the next language is like 1/10 as hard. Now that may not strictly be true because each language adds things, that Python might not have, or that Java, right? But the same, once you get the concepts down, learning other languages is far easier. That's why you're all going to take C++ over the summer or in the fall, right? Maybe not. Be cool to see you. Alrighty, so let's print this out. This is a parallel array, right? Because we had 7 days of sales, and we have 7-day names. So we can use yet another for loop for I in range, parentheses, len, parentheses, days. I just chose days arbitrarily. Could have been sales. In parentheses, print days, subscript I, comma, quote, a tab, so quote, \t, backslash being the one above the enter key, end quote, comma, and then sales subscript I. Now we can make it look a lot better if we use formatted, right, like the %, %.2f to make sure it's cents, and specifying the width of the column, and putting a $sign there, but this is enough to prove the point. I guess I could put a $sign there, right? I don't know. I don't know if that's going to make it look pretty or not. I think that makes the syntax more confusing. I'm going to leave the $sign off. All right, and there's our sales. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Wouldn't it be neat if we didn't have to do this step? If we could just do this step, right, define our month names. We kind of had to do the same thing twice, but it's fine. What if we wanted to print this out in Spanish? We could just substitute the Spanish, months for the, the English months, whatever. I don't know what they are. It's been a long time since high school Spanish. They still make y'all take languages? People had to take Spanish or French in your high school? Yeah. Alrighty. We're an hour into it. We can squeeze in a few more minutes of lecture. You can use a loop to fill a list. Like if I wanted to put $10 into Monday and $20 into Tuesday and $30 into Wednesday and whatever, we could fill up the sales array like that if we had any need to. Let's do that. For I in range subscript, len subscript sales in subscript colon. And what's our formula going to be? Well, since I is starting at 0, I think what I'm going to do is add 1 to it and then multiply it by 100. So to say 100, 200, 300. I'm just picking that arbitrarily because I think it'll be interesting to look at. So sales subscript I equals, and I'm just going to make up a formula. I plus 1 in subscript times 100. Then I'm going to copy this right there, just because I want to print it out again underneath it. See the effects of my changes to the sales. So I just took that for loop with the print statement. Exact same thing. I just wanted to see it printed out again with 100, 200, 300, 400. And there we go, right? These were our sales before our change. And then for some random reason, our boss decided that we were going to sell $100. Maybe these are our goals, right? Whatever. Now I almost hesitate to show this to you, but I'm going to anyways. I doubt you're going to do this in any of your homework, so you can just tuck it away in your head. In this language, you can use a range to fill your array. And what do I mean by that? I could do this. Sales equals list subscript range subscript, and I wanted to start at 100 and I wanted to end at 700. So 100 comma, but I have to put one more value, right? We've talked about that before. 701 and I want it to go up by 100 each time. And then since I have two opening parentheses, I'm going to make a closed parentheses. And then if I printed it out one more time, we're going to see the exact same results. Maybe I should just make it 10 to 80 by 10s or something like that, or 20 to 90 by 10s or something like that. But this just does the exact same thing as this before, and you see what it's doing. You could figure out what this range is counting. It's starting at 100. Each time it adds 100 to it, and it's going to stop before it hits 701. So it's going to do 100, 300, 200. I'm not sure that I did that right. Let's find out. Well, how would I know, right? Because it's the same thing as this one before. I'm going to temporarily comment that one out. I'll uncomment, so don't make that change. All right, and it did it. It did it. It did the same thing. So I'm going to uncomment those print statements out. Do I want you to know how to use a range to fill an array? What would the use of that be? Only if you're going to add an exact sequence, right? The same kind of stuff you've used ranges for, right? So if you know exactly in advance, this doesn't work in other languages. It's just to show you that you can use a range statement. So what is this doing? It takes that range, it converts it into a list, and remember that we're saying that lists and arrays are the same thing. I don't really expect you to know the above syntax. It fills the array with the results of the range, not the range. So 100, 200, 300, 400, 500, 600, 700. And you know why it stops at 700? Because we put 701 there. That's about enough. Let's go check out what homework is coming up to make sure we've adequately covered it. Let's add a comment to this one though, showing what that one did. The above uses a formula to fill in the array with a sequence of values. If we took the +1 out, it would just start at 0 rather than 100, right? So it'd say 0, 100, 200, 300, 400, 500, 600. That's the only reason I put that +1 there. I guess I'll add a parenthetical comment, which is exactly what the for loop up above did, which is actually what I would prefer you to memorize. All right, I'll go back to this if y'all have syntax errors, but I want to grab the homework first. Create an array called movies. I want you to initialize it with the names of 5 movies you like, or call the arrays books, you don't like movies, or artists, right, you like Vincent Van Gogh, whoever, or songs, or whatever, and fill it in with the appropriate data of your choice. And then write a print statement that will print the length of the array, like len parentheses movies. You could make it a little bit better by saying the array is len movies items long, something like that. And then write a loop that will print every movie in the array, like this. Now you don't have to use my 5 movies, right? My favorite movies are Twilight, Finding Nemo, Cars, Cars 2, and Cars 3. Kind of interrupt there towards the end. And then part 2, create parallel arrays called colors and foods and initialize them with values so that you can write a loop that prints the color of each food. I didn't tell you how many foods and colors to put in it. I'd kind of like for you to do at least 3. So I like red grapes, I like green pizza, I like blue cheese. So I would have an array called colors, an array called foods, and I would have a for loop to print that out. And like I said, you don't have to use the same colors and foods I use, or the same movies. So today's lecture covered how to do all this. You could do either one of these things with the initializer list, like I showed you here, right? Colors is equal to, and then you could put in 3 colors there between the braces and the foods and the movie names, right? Or you can do it like we've been doing up here, right, where we set each one individually. I'd kind of like for you to prove that you could do it one way and then the other, right? Maybe do the movie names like that, and then do the foods and the colors like that, but you don't have to. You can figure out how you want to do it. Make sense, gang? I see some people nodding. Nobody waving their hands and saying, no. All right. Well, let's stop there.
This is T, right? Lecture T.
Yep, lecture T, I need to make a Dropbox.